Have you ever looked up at the night sky and felt a sense of wonder? The stars twinkle like tiny, distant diamonds scattered across a vast, dark canvas. For thousands of years, humans have stared into this cosmic ocean, asking big questions about our place in the universe. We've mapped constellations, discovered planets, and even sent robots to other worlds. But some things in space remain deeply mysterious, hiding secrets that challenge everything we think we know. These mysteries are part of the grand story of the cosmos, a story that includes our own planet, our sun, and every living thing on Earth. Right now, as you read this, you are traveling through space at an incredible speed. Our entire solar system is orbiting the center of our home galaxy, the Milky Way. At the very heart of our galaxy, about 27,000 light-years away from Earth, lies a monster. This black hole is truly enormous, containing the mass of more than 4 million suns, all crushed into a single infinitesimally small point. But here is a surprising fact. For a monster of its size, Sagittarius A is remarkably quiet. Scientists often refer to it as a sleeping or dormant black hole. For a supermassive black hole, waking up is a violent and spectacular process. It means the black hole begins to feed again, and it does so with incredible ferocity. Imagine a calm, still pond. If you toss a single pebble into it, you get a small ripple. But if you drop a massive boulder into it, you create a huge splash and powerful waves that churn the entire pond. Instead of falling straight in, this material is pulled into a rapidly spinning whirlpool around the black hole, forming the bright, hot accretion disk. As the matter gets closer and closer to the event horizon, the point of no return, it spins faster and heats up to millions of degrees. This process transforms the black hole from a quiet, invisible object into a brilliant, blazing quasar, one of the most luminous phenomena in the cosmos. This sudden awakening would have dramatic consequences that would be visible across the galaxy. Imagine a star, much more massive than our own sun, reaching the end of its life. It runs out of fuel and can no longer fight the inward crush of its own gravity. In a final, spectacular burst, it explodes as a supernova, blasting its outer layers into space. Now take that idea and make it bigger, much, much bigger. A supermassive black hole is not formed from a single star. Instead, scientists believe they grow over billions of years, starting from smaller seed black holes in the early universe. Think of a supermassive black hole as the ultimate cosmic vacuum cleaner, but with a twist. It doesn't actively suck things in from far away. Its power lies in its immense gravity, which warps the space around it. Hidden behind thick clouds of interstellar dust and gas, about 27,000 light-years from Earth, is our very own galactic monster. Its official name is Sagittarius A, pronounced Sagittarius A star, or Scar A for short. This is not just any black hole. It is the supermassive black hole around which our entire galaxy revolves. Every star, every planet, including our own solar system, is locked in a slow, cosmic dance around this central point of immense gravity. The final number is astounding. Sagittarius A contains the mass of about 4.3 million suns. Imagine taking 4 million stars like our sun and crushing them all down into a space so small it is effectively a single point. But in 2022, science took a monumental leap forward. Using a global network of radio telescopes called the Event Horizon Telescope, astronomers captured the first ever direct image of it. The image revealed a blurry, donut-shaped ring of glowing gas, superheated and swirling at relativistic speeds around a dark central region. Despite its colossal mass and power, Sagittarius A is surprisingly calm. Astronomers classify it as a sleeping or dormant black hole. Sagittarius A is on a very strict diet. It is not currently feasting on any large objects. Our galaxy, thankfully, is a calm and peaceful spiral, a safe haven for life to evolve. If Sagittarius A were to become active, the consequences would be devastating for the inner galaxy. The universe is a dynamic place, and nothing stays the same forever. The peaceful slumber of Sagittarius A is not guaranteed to last. Imagine the stars orbiting the galactic center. They are not on perfect, neat tracks like planets in a solar system. Instead, they follow complex, overlapping orbits in a crowded cosmic dance. Sometimes two stars can have a close encounter, a near miss that changes their paths. One star's gravity can give the other a powerful gravitational slingshot, sending it careening off its stable orbit and onto a new, dangerous trajectory straight toward the black hole. Our Milky Way is not alone in the universe. It is part of a local group of galaxies, and we are on a collision course with our largest neighbor, the Andromeda Galaxy. The Milky Way is constantly absorbing smaller dwarf galaxies, tearing them apart with its gravity and swallowing their stars and gas. If one of these dwarf galaxies were to pass through the galactic center, it could cause massive gravitational disruptions. It would be like stirring a pot, disturbing the stable orbits of countless stars. A future merger, even with a small galaxy, could be the alarm clock for Sagittarius A. The sleeping giant would be presented with an all-you-can-eat buffet, and the process of waking up would begin with a ferocity that our galaxy has not seen for a very long time. So what happens when an unlucky star gets knocked onto a collision course with Sagittarius A? The result is, honestly, one of the most spectacular and violent events in the universe, a tidal disruption event, or TDE. As the star gets closer to the black hole, the gravitational pull on the side of the star nearest the black hole becomes immensely stronger than the pull on the far side. This massive difference in gravitational force, known as a tidal force, starts to stretch the star. As the star is unraveled, it is torn apart with unimaginable violence. The star's internal structure fails completely, and it essentially explodes, but not from a fusion reaction like a supernova. Instead, it is shredded by pure gravity. About half of the star's material, now a superheated stream of gas and plasma, is flung away from the black hole at incredible speeds, escaping back into the galaxy. The other half, however, is captured. This captured stream of stellar guts does not fall straight in. It forms a new, brilliant accretion disk around the black hole. The formation of this new accretion disk is the true moment the black hole wakes up. The quiet, dark region at the center of our galaxy would suddenly erupt in a brilliant flash of light, producing a flare of X-rays and ultraviolet radiation that would be visible to our telescopes here on Earth. A single star is a tasty snack for a supermassive black hole, but to truly awaken the giant and turn it into a powerful quasar, it needs a much bigger meal. This is where giant molecular clouds come in. A galactic merger or a gravitational disturbance could send one of these immense clouds on a one-way trip towards Sagittarius A. As it approaches the black hole, it does not get spaghettified in the same way. Instead, it gets compressed and fragmented by the intense gravity. This is not a neat single stream of material, but a messy, chaotic downpour of cosmic fuel. It is like turning on a fire hose and pointing it directly at the black hole. This galactic downpour would create an accretion disk far larger, denser, and more powerful than one from a single star. The accretion disk would swell to an enormous size, glowing with the energy of 1 trillion suns. The light from this awakened core would be so intense it would outshine all the 400 billion stars in the Milky Way combined. For any civilization living in our galaxy, it would be like having a second sun ignite in the sky. If Sagittarius A were to wake up by consuming a massive gas cloud, it would not just glow, it would shout its presence across the cosmos. The intense heat and friction within the swirling disk of gas would generate mind-bogglingly powerful magnetic fields. These magnetic fields, twisted and amplified by the black hole's spin, would act like a colossal particle accelerator. They would capture charged particles, protons and electrons, from the hot gas and funnel them into 2 narrow focused beams. These are known as relativistic jets, and they are among the most powerful phenomena in the universe. These jets would be like cosmic lighthouses, but instead of harmless light, they would spew deadly radiation. They would be incredibly focused, like laser beams, and would travel for thousands or even hundreds of thousands of light years. They would slice through the galaxy like cosmic blowtorches, heating everything in their path to millions of degrees. Fortunately for us, Earth is not aligned with the rotational poles of Sagittarius A. Our solar system orbits within the flat plane of the Milky Way's disk, so we would not be in the direct path of these terrifying jets. However, we would not be entirely unaffected. The jets would collide with the gas and dust in the interstellar medium of our galaxy, creating powerful shock waves that would ripple through the galactic disk. While the jets are a focused danger, the light from the accretion disk itself would be an inescapable spectacle for the entire galaxy. As Sagittarius A feasted on a star or a gas cloud, its accretion disk would blaze with the light of 1,000,000,000,000 suns. From our vantage point, some 27,000 light-years away, this sudden eruption of light would be the most dramatic astronomical event in human history. The center of our galaxy would become a brilliant point of light in our night sky. Scientists estimate that an awakened Sagittarius A could easily outshine every other star in the sky. At its peak, it could appear as bright as the full moon, or potentially even brighter. Imagine looking up at night and seeing two moons. This new star would be visible during the day, a constant reminder of the monster that had awakened at the galaxy's core. This new light would not just be beautiful, it would be dangerous. The accretion disk would not just shine in visible light, it would be a powerful source of high-energy radiation, particularly X-rays and ultraviolet light. While our atmosphere does a fantastic job of protecting us from the sun's UV radiation, this new source would be millions of times more powerful. A significant portion of this deadly radiation would flood our solar system. Beyond the light and the jets, an awakened Sagittarius A would unleash another, more insidious danger, a storm of cosmic rays. Cosmic rays are not actually rays, they are high-energy particles, mostly protons and atomic nuclei that have been accelerated to nearly the speed of light. They would pick up particles and fling them out in all directions, creating a blizzard of tiny, super-fast bullets that would travel throughout the entire galaxy. Our planet's magnetic field and atmosphere protect us from the worst of the cosmic rays that currently hit us from distant sources. However, a newly awakened Sagittarius A would be a source within our own galaxy, vastly increasing the number and energy of these particles. This cosmic ray storm would pose a serious threat to all life. On the surface, the increased radiation would lead to higher rates of genetic mutation in plants, animals, and humans. The danger would be even greater for air travel. At high altitudes, the atmosphere is thinner and provides less protection. Airline passengers and crew would be exposed to significantly higher radiation doses. For space exploration, the consequences would be even more dire. Astronauts would be exposed to a relentless barrage of high-energy particles, making long-duration space travel far more dangerous. The awakening of Sagittarius A would not just be a temporary light show, it would fundamentally reshape the physical environment of our entire galaxy. Star formation happens in giant, cold, dense clouds of molecular gas. The intense energy blasting out from the active galactic nucleus would heat up these clouds, preventing them from collapsing to form new stars. This process is known as galactic feedback, and astronomers believe it is a crucial part of how galaxies regulate their own growth. An active black hole essentially acts as a thermostat for its host galaxy. The Milky Way, currently a vibrant blue spiral with active star-forming regions in its arms, would slowly begin to redden and die. It would transition from a lively star-birthing galaxy to a more dormant, red and dead galaxy. The structure of the galaxy itself would also be altered. The colossal jets would carve out immense cavities in the interstellar medium above and below the galactic plane. We can already see evidence of a past, less powerful outburst in the form of the Fermi bubbles. Two giant gamma-ray emitting lobes extending 25,000 light-years from the galactic center. Imagine the moment the news breaks. It wouldn't come from just a single observatory, but from a global chorus of astronomers, all pointing their instruments at the heart of the Milky Way, all witnessing the same unbelievable event. This news would spread faster than any story in human history, instantly capturing the attention of every person on the planet. The brilliant new star in the sky would become a constant, inescapable presence. It would be a source of awe, inspiration, and for many, deep-seated fear. New myths and religions would form around this celestial beacon. Some might see it as a divine sign, a message from a higher power, while others would view it as a harbinger of doom. Art, music, and literature would be forever changed, as creators around the world grappled with humanity's new reality. This shared experience would likely foster a new sense of global unity. Faced with a celestial phenomenon that affects all of humanity equally, we might finally see ourselves as a single species, Earthlings, living together on one precious world. For the scientific community, the awakening of Sagittarius A would be the single greatest opportunity in the history of astronomy. It would be like a biologist suddenly discovering a living dinosaur. Every telescope on Earth and in space would be retasked, pointed permanently toward the galactic center. The data that would pour in would be overwhelming. We'd have a front row seat to the most energetic processes in the cosmos. We would watch in real time as the accretion disk forms, heats up, and launches powerful jets. This event would also force us to accelerate our technological development at an unprecedented rate. Faced with the new reality of a more radioactive galaxy, research into radiation shielding would become a top global priority. Perhaps most profoundly, studying the awakened monster would bring us closer to answering some of the deepest questions in all of science, potentially finding the first clues to a theory of quantum gravity. The long-term impact of Sagittarius A's awakening would force humanity to think on timescales we have never considered before. The effects of an active galactic nucleus would unfold over thousands and even millions of years. These aren't problems that can be solved quickly. They are challenges that would become part of our shared inheritance, a legacy passed down through countless generations. This would necessitate the creation of new kinds of institutions. Just imagine a scientific and cultural organization designed to last for 10,000 years, tasked with monitoring the galactic center and preserving the knowledge needed to protect future generations. We would need to develop new ways to store information that could survive for eons, maybe etching our knowledge onto durable materials or even encoding it in our very DNA. This new perspective might also reignite our ambition for space exploration, but with a new sense of urgency. With our home galaxy becoming a more hostile place, the dream of becoming a multiplanetary species would transform into a practical necessity. The awakening of Sagittarius A would be a terrifying end to our galaxy's peaceful era, but it could also be the beginning of humanity's journey to becoming a truly cosmic civilization. We began this journey by looking up at the quiet night sky, a canvas of serene and distant stars. We've since traveled to the very heart of our Milky Way galaxy, to the lair of a sleeping giant. We've learned that Sagittarius A, our galaxy's supermassive black hole, is a monster of incredible power, containing the mass of over 4 million suns. For now it slumbers, sipping only on tiny scraps of interstellar gas. We explored the triggers that could shatter this peace. A single star, nudged from its stable orbit, could find itself on a one-way trip to the galactic center, stretched and torn apart in spaghettification. Or, on a grander scale, a colossal cloud of gas could begin a chaotic downpour of fuel, awakening Sagittarius A and transforming it into a brilliant quasar that could outshine all the stars in our galaxy combined. The consequences of this awakening would be profound and far-reaching. The heart of our galaxy would erupt with deadly radiation and launch colossal jets of high-energy particles, cosmic blowtorches that could sterilize vast regions of space. This cosmic event would reshape human civilization from the ground up. It would become the single, unifying story for every person on Earth, inspiring new art, new myths, and new fears. Reflecting on the possibility of Sagittarius, a waking up forces us to adopt a new and humbling perspective. It shows us that we are part of a much larger cosmic ecosystem, one governed by forces of unimaginable scale and power. We are living on a small rocky planet, orbiting an average star, in a quiet suburban arm of a galaxy that contains a dormant monster at its core. Our current era of peace and quiet is just that, an era, a temporary phase in the long and dramatic life of the Milky Way. This cosmic perspective is not meant to make us feel insignificant or powerless. Instead, it should fill us with a profound sense of awe and wonder. We are the universe's way of knowing itself, capable of looking out into the void, discovering its rules, and piecing together its history. Scientists at this very moment are continuing their watch. With instruments like the Event Horizon Telescope and powerful X-ray observatories, they are monitoring the galactic center, looking for any changes in its faint glow. This quest for knowledge connects us to something larger than ourselves. It reminds us that while our daily lives are filled with earthly concerns, we are also voyagers on a cosmic sea. And so we are left with a final, lingering question. One that we can whisper into the vast, silent void. As we look up at the stars, aware now of the sleeping monster that lies hidden among them, we must ask ourselves, is this peaceful moment in our galaxy's history a rare and precious anomaly, a lucky break in an otherwise violent cosmos? Or is the universe filled with quiet corners like our own, countless other sleeping giants allowing for countless other chances for life? We do not yet know the answer, and perhaps our own future and our place in the universe depends on what it turns out to be.